Welcome to this course module. In the last course module about routing, we had first contact with observables. Now, I want to dive deeper into observables in this section. Now, you could create a whole course about observables, so we're not going to dive that deeply into them, but I want you to understand what observables actually are and what you could use them for and why Angular uses them. So what is an observable? An observable basically can be thought of as a data source. Now in our Angular project, an observable basically just is an object we import from a third-party package, RxJS. The observable here is implemented in a way that it follows the observable pattern. So we have an observable and we have an observer. In between, we have a stream, a timeline. And on this timeline, we can have multiple events emitted by the observable, or data packages, you could say, emitted by that observable, depending on the data source of that observable, of course. So the observable could emit data because you trigger it to do so. You can do that programmatically. It could be connected to a button, and therefore whenever the button is clicked, an event in a data package is emitted automatically. Or as the Angular HTTP service does it, it's connected to a HTTP request. So when the response returns, the response is emitted as a data package. And there are dozens of other data sources too. We will have a look on where to find more soon. So as I said, the other part is the observer. This actually is your code, you could say. It's this subscribe function you saw earlier, or at least it has something to do with that. There, you have three ways of handling data packages. You can handle the normal data, you can handle errors, or you can handle the completion of the observable. Because these are the three types of data packages you can receive. And in these hooks, in these boxes, you could say, your code gets executed. So you can determine what should happen if I receive a new data package, what should happen if I receive an error, what should happen when the observable eventually completes. Side note, an observable doesn't have to complete. There are observables, for example, hooked up to a normal button, which never complete, because how would you know when it completes? A user could click the button how often the user wants, right? Other observables, like the HTTP request on the other hand, will have a clear end and will complete eventually, because once the response is there, what else should happen? It's done. So this is how the observable pattern generally works. And of course you use it to handle asynchronous tasks. Because all these data sources here, user events triggered in your code or a HTTP request, are asynchronous tasks. You don't know when they will happen and you don't know how long they will take. So if you execute your normal application code, you don't want to wait for these events, or you don't want to wait for the completion of such a HTTP request, because that would block your program, would block your logic. Therefore, we need methods of handling such asynchronous tasks, and historically you might have used callbacks or promises, and it's not necessarily bad to use them. Observables is just a different approach of handling that, a different alternative, and Angular embraces observables, which is why, well, I chose to explain these, because Angular uses them a lot. And actually, observables have one major advantage: they're operators, which I will show later in this section too. Back to this slide. So we got our observable and we got our observer with the three buckets, you could say, or with the three hooks where different code is executed depending on the type of package we receive. And then exactly this happens. The observable might emit a couple of normal data packages, it might emit an error, or eventually it might get completed and the respective code is then executed. So that's the theory. Let's now take a closer look in our actual project. Attached, you find the very simple Angular project, where I essentially only have three links that take me to different pages for two different user IDs here and to the home page. Now, of course, there is one thing we already learned about in the routing section, and that can be found in the user component, which you find here in the user folder in that attached project. In the user component TypeScript file, of course, I have already set up a subscription to listen to changing route params, so that if I am on the user page, as I'm here, because user 1 and user 2 share the same component, if I'm here and I have the user ID 1 loaded and I click on user 2, this updates here in the DOM, even though it technically is the same component, and that is something you'll learn about in the routing section. Now, this is using an observable. Params here is an observable to which we subscribe. And that's just one thing you can already keep in memory. Observables are constructs to which you subscribe to be informed about changes in data. Because remember, observables are that stream of data, and whenever a new data piece is emitted, our subscription will know about it. So in this case here, params is the observable. It's a stream of route parameters, and that stream gives us a new route parameter whenever we go to a new page, whenever that parameter in the URL changes. And then here in this function we pass to subscribe, we get the new params, and we can extract our relevant param, in this case the ID param, from that. So that's how this built-in observable works and how you can think about it. Params is the observable, it's that stream of data that gives us new values. Now that's all nice, and Angular will heavily use such observables, and there you will never need to create them yourselves. You only subscribe to them, you don't need to create them, but to understand them, it certainly doesn't hurt to also create them. So let's do that as a next step. Let's build our own observable from the ground up and understand its internals. To build our own observable, I'll go into that home component, and there in ng-on-init, I want to build a new observable. Now, observables are a feature that's not baked into JavaScript or TypeScript. Instead, they're added by a package named rxjs. And that's why in Angular projects, if you have a look at package.json, which lists all your dependencies, you find rxjs here. Now, in the home component, I want to build my own observable here in ng-on-init. And for that, we can import something from that rxjs package. So let's import from rxjs, and we don't need to do that when using observables, because thanks to TypeScript, it understands that params is an observable, and therefore it knows we can subscribe there, and we never need to explicitly inform it about the type. But if we want to create a new observable, we need certain features from that rxjs package. To be precise, that rxjs package gives us different ways of creating a new observable. And one of the easiest ways is the interval method, the interval function. You can just import interval like this, and then here you can call interval and pass in a number. And that is a bit like set interval, where you pass a number in milliseconds that will fire an event every X milliseconds. So if I pass 1000 here, then every second a new event will be emitted. Now this gives us an observable, and therefore we can subscribe to the observable here. And there I can now get my count. You can name this whatever you want and handle this or use this inside of this function. So I'm passing an anonymous function here to subscribe. That's the first argument we can pass to subscribe. It's the handler for all the data values that are emitted. So I pass this in, it gets the value that is emitted as an argument, and I just name this argument count because it turns out it will be an incrementing number for interval. We'll later also build an observable entirely from scratch, where we fully control the emitted values. Here we'll take this half measure, which is a built-in function that gives us an observable, but still it's more from the ground up than the ones Angular ships with. So here we have interval, which will fire a new value every second. And in this function here, I will simply console log count. So the idea now is that we get a new value emitted every second, and we log that to the console. Now let's save all files and open the developer tools here in our browser. And there, let's go to the JavaScript console and navigate to the home page. And there you should now see incrementing values being logged to the console, one value every second. And that, of course, comes from that interval function that gives us an observable. And again, this is not an observable we built entirely from the ground up, but it's pretty close. Now, when I navigate away now to user 1, you see that this keeps on counting. And that is something you have to be aware of. Observables don't necessarily stop emitting values just because you're not interested in them anymore. There are certain observables that emit a value once and they're done, like for example an HTTP request where you get back a response, something you'll see later in the HTTP module of this course. But there are other observables that keep on emitting values. And to stop that, and therefore to prevent memory leaks, which you would otherwise introduce if that keeps on emitting whilst you're not interested in it anymore, you should unsubscribe from any observable in which values you are no longer interested. And that's really important because before we do that, watch what happens if I go back to the home page. I'm on user 1, I was on home before, now I go back to home. What you now see is a new observable started. So we have the old one going on and a new one. And of course we can repeat that. We get more and more observables counting, and that of course is very bad. If that happens behind the scenes, you quickly run out of resources and you slow down your app, you introduce a memory leak here because your memory gets occupied a lot by data you don't need. So you definitely need to clear that. And to do that, we should store our subscriptions. And here I'll then name this first obs subscription. You can name it whatever you want. And the type of this private property of the home component will be subscription. And subscription also needs to be imported from RxJS. So make sure to add this import. And now here, subscribe actually returns such a subscription. So when we subscribe, we can store that subscription in our first ops subscription property. So we're not storing the observable here, that's the observable, but we instantly subscribe here, and therefore we store whatever subscribe returns, and subscribe returns a subscription. Now, the idea behind storing the subscription simply is that we now can also implement onDestroy here, which you need to import from @AngularCore, and that forces us to add the ng-onDestroy lifecycle hook. And inside of ng-onDestroy, we can now use our subscription and call unsubscribe. And that means that whenever we leave that component, we clear that subscription. And therefore, we prevent memory leaks because we're not keeping old subscriptions around. Now, if you save that and reload the app, you see our observable starts again. But if I navigate away, we get no new values. If I go back, it starts at 0 again, but the old observable is dead because we unsubscribed. And that's an important step. So this is an important step towards understanding observables. One common question I get is, okay, we unsubscribe here. Why don't we unsubscribe in the user component here, where we also set up a subscription? And that is a valid question. The answer simply is Angular does that for you. For the observables provided by Angular, like params, but also any other observable you'll encounter throughout this course that is provided by an Angular package or by a feature provided by Angular, all these Angular observables are managed by Angular. And therefore, you don't need to unsubscribe manually here. Angular will take care about this. So I promised you a custom observable to understand its internals, and what I gave you was interval. Now, it's closer to a custom observable because it's not coming from some Angular feature, but still this of course is kind of a utility function that gives us a predefined observable that fires a number every second. Well, actually, we can rebuild this manually. Let's comment out this code and let's build a real custom observable now. I'll store that in an observable, in a constant, and I'll name it custom observable or custom interval observable. You can of course pick any name you want. And to create a new observable, we can simply import observable, the type itself, from RxJS. Now you can use observable and call a create method on that, and this will do what it sounds like. It creates a new observable. Now, create actually takes a function, and I'll pass in an anonymous arrow function here, like this, which will get an argument automatically. RxJS will pass in that argument for us. And that argument is a so-called observer. Now, what's an observer? Now, you heard about the observer in the first video of this module. The observer, in the end, is the part that is interested in being informed about new data, about errors, or about the observable being completed. Now, our job here is to tell the observer about new data, about an error, or about the observable being completed. Here, we're not responsible for listening because the observer is the listener. Here, we get that listening part as an argument, and we need to tell it once we're done, once new data is there, and so on. So in this anonymous function, we can now use the regular setInterval method and set an interval of 1 second, let's say, as before. Now this again receives an anonymous function. It's the normal setInterval method, nothing special about that. And inside of setInterval here, we can now call console log or do whatever we want, or simply use our observer. And there, we now got methods like next. We can call next here to emit a new value. And that is important. The observer has a couple of important methods. Next is one of them. Error is another of them. So that would be the one you use to throw an error. And complete is one to let the observer know that you're done. Here, however, we use next. And to also have an incrementing number here, we can simply introduce a variable, count, which starts at 0. Inside of our setInterval, we then simply pass this on to next, and we then increment count by 1. So now here count starts at 0, we increment it by 1 whenever setInterval fires, and we let our observer know about that new data here. Now we can also subscribe to our custom observable. And I'll do this in the same place here in ng-on-init. Of course, you could do this in other places too, if this were stored in a service or in a property of that component simply. So here I can now call subscribe. And to subscribe, you pass the same thing as before. A function that simply accepts the data we're emitting. So in this case, we could name it count again, or to avoid naming confusion, simply name it data, whatever you want. And here I will now console log that data, just as before. Now let's save that all, and let's wait for this page to reload. And again, you see the same result as before. But now we built our own interval observable. And this is roughly what's happening under the hood here for the built-in interval observable too. It's giving us an observable, which will essentially fire for every X milliseconds we defined. And it lets our observer know about that new data. And that's what's happening here too. And if I navigate away, well, then we get a problem here because I tried to call unsubscribe of undefined because I don't store my subscription. Of course, that should be done here. So in my first op subscription, I'll now store that subscription again, simply by storing the result of subscribe in the subscription again. So now with that, if that reloads and I navigate away, that works without issues again. If I go back, a new observable starts. So this is working, and this is a real custom observable. And this shows us how to emit new data. But what about errors and completing the observable? I mentioned this as well. Emitting new data is arguably the most important thing observables do. And in, I'd say 99% of all cases, when you subscribe, you'll pass that first argument where you're interested in the data you're getting. Or maybe it's 90%, because there is one other important use case too, especially when we think about things like HTTP requests, and that is error handling. This counter here can't fail. There is no error that could occur here. But that's a different story if you're sending HTTP requests, which we will later do. So here, of course, we can also fake an error. We can simply throw one and define our own condition when we want to do that. Now, to do that, we could, for example, check if count is greater than 3. So if that occurs, then we'll, first of all, still emit that new data with the next method, but then we'll also use the error method to throw a new error here. So here I'll create a new error object, count is greater 3, which of course is a horrible event that definitely is worth an error. Now, if we do that and I save everything, let's see what happens. It starts counting again. And as soon as we exceed 3, we get an error here, right? We get our error that we defined. And you see that the observable now stops emitting. It actually gives us 4. which makes sense because that's the last value it emits before this condition is true. But there are no other values emitted, because whenever an observable throws an error, it cancels, it's done. It will not emit any other values, it dies, so to say. And therefore, in that case, you also don't need to unsubscribe. You still can unsubscribe if you navigate away, you'll not get an error, but it's not necessary because, well, it was dead anyways. But you might not have known that when you unsubscribed, so unsubscribing is not an issue. Now, this is how you can throw your own errors, and of course, it's more important to not just throw them. That most of the time will be done for you when you're using some built-in Angular functionality that can fail, like HTTP requests, but it's important to know how to handle that. And for that, you can pass another argument to subscribe. Thus far, we passed the first argument, which is this data function. The second argument would be our function that gets called when an error occurs, and we'll get the error as an argument there. Now, of course, the simplest thing we can do here is that we log that error to the console. But obviously, you could do way more than that. You could send it to your own backend and store it in a database there. You can show an error message, an alert to the user. Let's actually do that. Let's show an alert. And let's show the error message here in the alert. So that's what we're doing here. We're logging it to the console. We're showing an alert. And now it starts counting again. And as soon as we exceed 3, here you go. Now we get our alert. And you see we don't have that red error here on the right anymore. Instead, it's now a regular console log because that's what we're doing. So now we're handling that error. And that, of course, is also an important part. Now, handling errors is nice, but what about completing the observable? I told you that throwing an error actually cancels the observable and lets it die, but completing it is something different. Completing can be a normal process in an observable. Now, our interval by default doesn't complete. It will emit new values until the end of time. An HTTP request, on the other hand, will complete. It completes whenever a response by the server is there. And of course, here, when we're building our own observable from the ground up, we can also complete this manually. In the end, we are defining how our observable behaves. Our event source is the set interval we have wrapped in our observable. And therefore, before we throw an error, let's say, we can also add another condition, say, if count is equal to 2, well, then we simply call observer complete. And there you don't need to pass any arguments. Now, when you call complete, the observable will really come to a halt. And you can see that if you now reload, it logs 0, it logs 1, it logs 2, and that's it. Doesn't log anything else, doesn't reach our error condition because we complete the observable before it gets there. And that is important to understand and to keep in mind. Whenever an observable completes, it really is done. There are no other values emitted thereafter, which kind of makes sense because, well, it completed. Now, if you want to react to that completion, you can add a third argument to the subscribe method, and that is your completion handler function. It's a function that gets no arguments, because completing doesn't pass any arguments, and it's simply a function where you can do some cleanup work or whatever you need to do. And here I'll just log completed. Also important, you don't need to unsubscribe if your observable did complete, but again, you might not know that here in ng on destroy, so you can still do that without getting errors. So if I reload now, we see our logs again, and after the 2, we see completed. Now, also worth noting though, and important to keep in mind, you might think that complete, so that complete function here, also fires when you're getting an error. After all, the observable does finish after throwing an error, right? Well, that's not the case. If we change the complete condition here temporarily to, let's say, 4, and therefore this to 5, let's say, and therefore this will happen after this condition, which actually will throw an error, you will see something that might surprise you. We see our normal output here, and then we get that error, and that's it. What you don't see anywhere is our completed log. So this here never gets logged. And that's just one important characteristic you have to keep in mind about observables. When it cancels due to an error, then that's a different thing than when it completes. An error cancels the observable, it does not complete it. Technically, in both cases, no new values are emitted, but regarding the functions that get called here, there is a difference. That was a lot of talking about observables, but now we have an example of an observable and how it behaves under the hood. However, I know that this can look even more confusing, and you might ask yourself, well, when do I write this code? Because that's nice about the interval, but come on, I don't need that interval that often in my application. And you would be right, and by the way, if you needed one, you'd of course use the built-in interval function and not build your own one. So what's the idea behind that example? The idea is that you understand what happens inside of an observable. Whenever you subscribe and you set up your different handler functions here, RxJS in the end merges them all together into one object and passes that object, the observer, to the observable. And inside of the observable, it will then interact with the observer and let the observer know about new data and errors and so on. And that is how your functions get called. However, you rarely, very, very, very rarely build your own observables. More often, you use observables that come with libraries like Angular, like the route params observable we already used. Under the hood, that in the end is a custom observable built by the Angular team, but of course you just use it like that. You rarely build your own ones, but still, it's super important to understand how they work under the hood. And in the end, they all work a bit like that. They wrap some event source. In this case, it's setInterval. In other cases, it could be an AJAX request or a click listener or whatever it is. And they give you data or possibly also errors or the complete event. And you will mostly use subscribe and pass in functions that deal with that data or those errors. Now, it's all nice what we learned, but there's one super important thing about observables and the RxJS library that you absolutely have to know, and that would be operators. Operators are the magic feature of the RxJS library, and they are the thing that really turn observables into awesome constructs. If we have an observable and an observer, we of course get data, and we listen to that with a subscription. That is what you learned. Now, however, sometimes you don't need the raw data. You might want to transform it or filter out certain data points, and of course you could do all of that inside of your subscription or in the function you pass to your subscription. But there's a more elegant way. Instead of setting up that subscription like this, you can use built-in operators in between. That means that the data points, first of all, reach these operators that do something to the data, and that something can be anything. There are tons of built-in operators. And then you subscribe to the result of these operators. Now, let me show you a concrete example that makes that clearer. Let's say here, in our application, we of course get our values 0, 1, 2, 3 before we get an error. And let's say I'm not interested in these values, but I want to have some text that says something like round 1, round 2, round 3, and so on. So in the end, I want to use that count, add 1, and add the word round in front of it. Now, obviously, what we can do is we can simply log round plus data plus 1 here, add extra parentheses around that so that it is really used as a calculation. And if we do that, well, we see round 1, 2, 3, and so on being logged here. Now, nothing wrong with that. And for simple transformations like this one, of course, that makes sense. But the more complex your logic gets, the nicer it might be to not care about that here in the place where you subscribe, but in an earlier place. So here I'll revert this to just logging the data, and I want to change the format in which that data arrives. Now, obviously, we could do that directly here, where we create our observable, but what if you don't own the observable? What if you wanted to change the route params, for example? You can't change the original code. And that is where operators are important. You can use them on any observable, like our custom interval observable, by calling a method called pipe. Now, every observable has a pipe method. The pipe method is built into RxJS. Now you can import observables, not from the RxJS package, but from rxjs/operators. And there are tons of built-in operators, like the map operator, which is one of the operators you'll use more often. As a side note, if you want to learn more about RxJS and operators and so on, you can visit my homepage, academine.com, and there on the Learn JavaScript, you'll find a complete series on RxJS, which introduces you to RxJS and to operators as well. It uses a slightly older syntax. RxJS was changed in the meantime, which I, by the way, also cover on my page. Here in RxJS 6 what changed, but the core idea and the explanation about these operators still applies. That can be very useful for learning more about RxJS. But that's just a side note. Back to our code here. So we have that pipe method and we're importing map here. And map, as I mentioned, is one of the more important operators. Now we simply call map as a function inside of pipe here. And map in turn takes a function as an argument. So an anonymous function here if you want. That, however, gets an argument. That anonymous function gets an argument. And that is the data you would otherwise get here in your first subscribe callback. So in that first function you pass to subscribe. It's the current data of your observable that's being emitted by that observable. So we get that data here. And in map, we now have to return new data. That can, of course, be the unchanged old data, in which case that map operator is totally useless. But it can also be transformed data. Like, for example, round plus data plus 1. So what we previously did right in console log. Now we're doing it here. We just have to be clear about the format of data here, as it seems. You can, of course, do that by wrapping data in parentheses here in the argument list, adding a colon after it, and making it clear that this will be a number. And now if you save that, it will compile. But what you'll see in your project now is still the old output. The reason for that is, let's wait for this to complete. The reason for that is that this is applied, but we still subscribe to this observable, and this does not change the data inside of the observable. Instead, it only changes the data we get after pipe. So what we would have to do here is simply we have to take that and replace our observable here with it. So the concrete observable we're subscribing to. Now if we do that, so if we have our observable, then we pipe the data, so we add a couple of operators, in this case the map operator. Then when we subscribe thereafter, we'll get that mapped, so that changed data. And now when we save this, we'll see that we get round 1, 2, 3, and so on. So this is the map operator. And again, just as before, this is kind of a constructed example here. It is, of course, more useful, for example, if you're fetching complex data from a web server and you want to transform that data before you use it in a component. And that is something we'll do later too. But the core idea is the same. With pipe, we can add one or more operators. If you have more than one, you simply add them as arguments here to the pipe method. So the pipe method takes an unlimited amount of arguments, and each argument would be an operator imported from RxJS operators. And you can add as many as you want, and they will execute after each other and do different kinds of stuff on the data. This is map. Of course, for example, you could also filter. That's another operator indeed. So let's use that just to demonstrate one more. Now, there are dozens, by the way. Besides using my page here, you can also visit learnrxjs.io, where you find a long list of the operators with examples. So that's really useful. But back to our code. Now let's dive into filter. And if we wanted to add that too, we would simply add it here, separated by a comma in front of map as an extra argument here. And filter also gets the data, of course. And inside of that anonymous function, which we pass to filter, where we do get that data, we now have to return true or false, which decides whether that data point will continue in that chain, so whether it will reach map and thereafter the subscription, or whether it will be dropped, in which case it will neither reach map nor the subscription. Now, of course, we could hard code true or false here, but that's not too useful. Instead, we could say, yeah, return true if data is greater than 0. And that effectively means that we will return every value but the very first one. And therefore, since we print round data plus 1, will not start with round 1 because we're dropping this 0 value. Instead, we'll actually start with round 2 because only then this condition is true. So if we now go back to our application here, let this reload, we see nothing but then round 2, round 3, and so on. So round 1 indeed is skipped. And that shows you, hopefully, the power of operators, that they allow you to build up a chain of steps you want to funnel your observable data through that can be really helpful when it comes to transforming data, filtering out data, and so on. Now that we learned so much about observables, we're almost done with that section and ready to continue, but there is one other important construct that you should not miss, and that is the subject. Now, what's the subject? Well, let's say in our user component here, we have a button, which I'll add, and I'll give it a class of button primary, and I'll give it a label of activate. Now, the idea is that when we click this button, we change something in the app component, so in a different component, and we simply print activated here, let's say. So we add another horizontal line, and in between, we want to print activated, but we want to only show this if we clicked activated on the user component. Now, how can we make this work? Well, with a service and an event emitter, for example. That is something you also learned about earlier. So let's quickly do that. Let's add a new file here, the user service.typescript file here next to the app component. And in there, I'll export a class, user service. Nothing too special. It will get the add injectable decorator, which is imported from add Angular core. And I will use the more modern syntax for providing it. I'll add provided in root here. Alternatively, you simply add it to providers in the app module here, which is also fine. But this is a shortcut, a shorter and easier way. Now we have that service, and in there, I'll add a property, activated emitter, which is a new event emitter, and event emitter is also imported from add Angular core. That's a pattern I showed you earlier already, and that event emitter will emit a Boolean. We can now use that event emitter from inside our user component if we inject that service here. So the user service is injected here. For that, of course, make sure to also import it from that user service file. And now we just need to add a new method on activate. And in there, I'll call my user service, reach out to activated emitter, and call emit, and pass true here as a value. And now the last step is to wire up on activate here in the user component to the button by adding a click listener to the button, and there I will call on activate. Thus far, nothing too fancy. That is a normal way of passing the data around, or at least of emitting an event across components. Now we want to listen to that event from inside the app component, and for that we simply inject the user service here too by using that injection shortcut also, where we automatically bind it to a private property named user service. And I'll then add a new property here too, user activated, which is false initially, and in ng on init we can set up a listener. We can reach out to the user service, activated emitter, and subscribe to it. And in there, we get our did activate, or whatever you want to call it, Boolean, and we'll set user, this user activated, equal to did activate. And therefore, whenever we emit true as a value here, user activated will switch to true. And in the app component HTML file, that now means that we can use ngIf here to conditionally show that paragraph as soon as user activated is true. Let's save all of that. Let's navigate to that user page here, and let's click activate. And indeed, we see activated here. So this is working, which of course is nice. This is the old approach with the event emitter. And this is an approach you could use, but there is a better one, a more recommended one. And that new approach, the better approach, uses a subject. Now, a subject is something we import from RxJS. So you import subject from RxJS. Instead of event emitter, you now create a subject here. Other than that, it's pretty similar though. It's a generic type where you define which data will eventually be emitted. In this case, a Boolean. So it's very similar to event emitter thus far. We also use it very similarly. In the user component, we don't call emit, however, but something you saw before already, you call next. Because a subject is a special kind of observable, you could say. We know observables, we can subscribe to them as you learned, but they're rather passive. You learned how to create your own observable, but the core idea always is that you wrap a callback or an event or something like that. A subject is different. A subject also is an object you can subscribe to, but it's more active because you can actively call next on it from outside. Remember, in the observable, we also called next, but that was from inside the observable when we created it. So that is a more active observable that is perfect when we want to use it as an event emitter. So if we don't have a passive event source, like an HTTP request or DOM events, but if we have something that actively needs to be triggered by us in our application. And that's exactly the use case we have here. We now can call next here in the user service on our activated emitter. The activated emitter is that subject. And in the app component, we still call subscribe because it is an observable and therefore we can subscribe. If you now save that, you click activate again, it still works, but now it's a subject. And whilst it technically, of course, works in a similar way, using a subject is the recommended way. Don't use event emitter, use subjects. They are in the end a bit more efficient behind the scenes. You can also now use all these cool operators because a subject in the end also is kind of an observable. So you have that too, which is a huge advantage, and it's simply something you can and should keep in mind. Use subjects instead of observables. One important note, just as with your own observables, you should unsubscribe to your subjects though whenever you don't need them. So add on destroy here to the app component, which you need to import, or to any other component where you set up a subscription to your subject. Store the subscription, activated sub is a subscription. Subscription needs to be imported from RxJS, so make sure to add that import in your file as well. Store that subscription then, so here where you call subscribe, you simply set this equal to activated sub, so that the subscription is stored here. And then you add ng on destroy, and inside of ng on destroy, you simply use your subscription and call unsubscribe. And now you have a great application without any memory leaks or anything like that. Now, one important note about subjects as a replacement for event emitters, this only counts if you're using them as cross-component event emitters, where you manually call next or previously emit. You don't use subjects instead of event emitter when you're using at output. So if you're using in a component, if you're using at output here, with your own event, you still use the Angular event emitter. You're not using subject there because the subject is not suitable for that. There you need the Angular event emitter. You only use subjects to communicate across components through services, so through a mechanism where you in the end subscribe to somewhere, like here in the app component. If you're not subscribing to an event emitter, then it probably is an output. If you do plan to subscribe manually, then it is a subject. That's it for observables. You saw how you can build your own observable to basically get an idea of what's happening behind the scenes, how you can subscribe to it and provide different functions to do different things for data, errors, or the observable being completed. You learned about operators, which you add by using the pipe method on the observable, and then by adding the operators you import from RxJS operators, which are tools that might not look super useful right now, but which will actually become quite handy throughout the course, since they make it easy for us to build nice code structures where we have a clear chain of steps we want to execute on the data we're getting, let's say, from a server, and therefore they're really powerful. And you learned about subjects, which are in the end a better event emitter, you could say. And with that, you have a thorough foundation about observables. Now also check out the advanced resources you find in the last lecture of this module, and which I also already showed you throughout this module if you want to dive way deeper. But with that, we now have all the preparation to continue with the course.